page 257. It says, if 1,200 square centimeters of material is available to make a box. Oh, yeah, you were thinking it's just the area of the base, but it's the area to make the box with a square base and an open top. So find the largest possible volume of the box. And it doesn't say that it's a cube, does it? It's a box, so it's like a box, like that. A square base, but couldn't the sides still be rectangles? So maybe that's where it was messing you up. So you would have, this is going to look really nice. I'm a really great artist. Close enough. Okay, so the base here is a square. So if we call that x, it would be like x by x, and then we would call this y here. Okay, and it tells you that you've got 1,200 for the box. So that it's a surface area, but we're not including the top. So the 1,200 would be your x squared plus 4xy's, right? And then you can solve this for y equals to plug it in. Is that making sense? And then you're trying to find the largest possible volume, so you write an equation for volume. You plug it in for the y, and then you should be good to go from there. So we'll stop it there. Okay, so we got a piece of wire here, and it says it's cut into 2 pieces. We're going to also make sure we think about the endpoints with this one, so where it's not cut, and all of it's used for one or all of it's used for the other. But let's assume here that it's cut for 2 pieces for our picture. And we've got one piece would be x, and the other piece would be what then, if the whole thing's 10? 10 minus x. Okay, one piece has bent into a square, and the other has bent into an equilateral triangle. So if we bend this part into the square here, what's the length of each side of that? 1/4 x. I'm just going to put x over 4 here. Okay, and then this one is an equilateral triangle. I'll draw this nicer because we might need it depending on your knowledge of an equilateral triangle. Okay, so if we bend this is going to be 10 minus x over 1? 3. And then we need the area, so we're going to need to cut this down here. Because for an area, we need that height, so we need to find what this height is. So if I use one of these triangles here to try to find the height, what do I know about the bottom of this triangle? It's half of this, which would give me what? Over 6. Is what? Is that making sense? Okay. And then you can find the height either using your knowledge of your 30, 60, 90 triangle, if you know that. And if you don't know it, how can you still find what the height is? Using your Pythagorean Theorem, right? This squared plus this squared is equal to that squared. So let's do that because you guys don't know 30, 60, 90, right? We don't teach it super well here at Prairie. Or do you know it? Yeah, so 30, 60, 90, this would be your 30 degrees. This would be your 60 degrees. And then your 90 degrees. But do you know the relationship in the 30, 60, 90 triangle? No, but the sine and cosine, you'd see it in like your unit circle, so that's probably where you saw it before. So let's just go ahead and set up our a squared plus b squared equals c squared. I'm just going to call it h squared for my height. Okay, so this part here would just turn into 10 minus x squared over what? 36. And this over here is 10 minus x squared over 9. So if I want to get h by itself, what would I do? subtract this over, right? And so I'm going to subtract 10 minus x squared over 36. So what would be our common denominator between these pieces? 36. So I have to times this by 4. So then this is going to get times by 4. So with that common denominator, 4 of these minus 1 of these is going to give me 3 of those. Yeah, the 36 and the 3 can simplify, so the 3 goes into 36 12 times. And then I still have to make sure I square root that. So when I square root that, what do I get for my numerator? 10 minus x. 2 square root of 3. And the other way you can do it is rationalize that denominator. So if you used your 30, 60, 90 triangle, you'd get an answer that's more like the rationalized piece here. So if I rationalize that denominator, it just means I get the square root out of the denominator. So what is the denominator going to be? 2 times 3, so 6. And what's the numerator going to be? And I'm just going to leave the square root of 3 out, but yep, 10 minus x times the square root of 3. Okay, so this height here is square root of 3 times 10 minus x over 6. So all you would have to do if you know the relationship is take this and times it by square root of 3 and you get there. Okay, so any questions on that part of it? Now let's finish reading the question because I kind of jumped into it because you guys had time to look at it. Okay, we got the 10 meters long. One piece is bent into the square, the other the triangle. How should it be cut so the total area is a max and a min? So our primary equation is talking about area here. So what's the area of this square? Yeah, so you could take this times this, so x squared over 16. Let's just do that. X squared over 16. Isn't that the same thing as 1/16 x squared? That's going to be easy to take the derivative of that way. And then plus the area of this. How do you find the area of a triangle? Half base times height. So I'm going to write it out here a little bit. The base is and then the height is does this all look right? Height. There we go. Okay, so for the area of the triangle, we're doing half the base times the height. So we only found this triangle here. We need the whole triangle, okay? So we'd have to double this. So instead of doing half, you could double it. Or you could change this part. Instead of being 10 minus x over 6, you do the whole base, which is 10 minus x over 3. Wouldn't you get the same thing whichever way you do it? I'll switch this to a 3 because that's what was brought up, okay? But yeah, you could multiply by 2 at the end and that would also work, so that would get rid of the half. So either way would work as long as you account for that. Thank you. Okay, and then I would clean this up and then find your derivative after you clean it up. Otherwise, it's going to get really messy here. So the 1/16 x squared is already easy to deal with. Okay, back here, we've got really a 10 minus x squared, and then we'll put all the constant stuff out front. So in the numerator, we have a square root of 3. And in the denominator, I've got what? 36. And then I've got 10 minus x squared. Does that look right to everybody? Okay, and then from there, take your derivative and try to set it to 0. So I'll work it out on the board while you guys work it out on your paper there. And this one I have to multiply by -1 because of the chain rule, so I'm changing the sign here. So if you're wondering where that negative came from, it's because I have to multiply by -1 back here. Does that look okay to people? And then set it to 0. So I just distributed there if you're following me at all. And then I'm going to move the constant piece over and pull an x out of these parts here. You could do this different ways as long as you'll get the same, value for your critical number. You should be good. There's different ways to go about doing that algebra. And then you just divide by this piece here. And then I'm just going to store that in my calculator. Just be careful typing that in your calculator. Because simplifying it, that would be good, but if we don't need to, then we won't. And we'll check to make sure we get the same decimal here, because it'd be easy to mess up that. So that's what you guys got?
Mrs. Riley, second hour Lisa, please report to the library for class today. When it comes to an and I'm please come to the
And then I'm just storing that as my A value here. So I've got that. I'm just going to drag it out here so I know what it is. Okay, so we got our A value. Are there any other critical numbers? Okay, so the other spots are not critical numbers, but the other spots I need to check are 0 and 10, because you could not cut it at all, and you could use it all for the square, or you could use it all for the triangle. So 0 and 10 would represent those pieces. So let's plug in here 0, and we'll plug in 10, and then I suppose we're using A and A. Maybe I should have used B here. I'm going to switch this to say B. And then I'm going to say I'm finding the value at B, so it doesn't look so weird there. In my calculator, it's still A, but for the reader, it says B there instead of looking so confusing. Okay, and then we go back to our actual A function here. So if I plug 0 in, this part would be 0. This part would be 100, so 100 square root of 3 over 36. You can type it in and get a decimal. Do the same idea for 10. 10 back here makes it easy. What's that going to be? 0, and then here we get 100 over 16, so you can type that in, and then plug the b value in using your calculator. Okay, so I think I typed that in right. So for that, I'm getting like 2.7185. Good. Yeah, how do you do fraction form? Because that I need to learn. Okay, so math over number, up. Okay, so the n over d and hit enter. Okay. Is there an easier way even? Oh, see, now I did it wrong. I'm used to like the calculator I used in high school and college, and they were not this nice. So Stephen was just showing us how to do the fraction in the calculator there. It looks nicer that way, and you are probably going to make less errors typing that way. So if you practice it in class, it's not a bad idea. So it's math over to number, and then if you click up one, it takes you right to the fraction piece. Oh, but you have to be careful of where you're typing that in. Practice with it, though. It'll probably help you on your AP test by then. So, okay, what was 100 over 16? 6.25, is that what you guys got? And what about the other one? Add 0. Is it, that look okay? Okay, so we've got these three values here, and we're trying to answer the two questions. So how should the wire be cut so that we have a maximum? So where's the maximum at? Here, right? So this is our maximum. If we want a maximum, we want our x to be 10. What does it mean if our x is 10? It's all used for the square. So for part A here, the max occurs when all the wire is used for the square. Okay, and then part B is talking about the min. So where does the min occur? Yeah, so at B here, so when our B value was this here, so when 4.350, is it in meters? Meters is used for what? For the square. And the rest is used for the triangle. You could find what that is, obviously, if you wanted to. Questions on that at all? You think it's too much work to spend, 10 or 15 minutes on a problem that could save your company millions of dollars? He is. Okay, so we're going to skip 59 and we're going to look at example 4 here. Okay, I want you guys to read this for a second and think about what all the pieces could be. See if you can label any other pieces. A couple pieces that we will want are the distance from here to here. So find an expression for that. And then also from here to here, you would want to find an expression for that. So I'll give you a couple minute head start. Okay, so it says this guy launches his boat. He's starting here at A. and it's straight across the river that's 3 kilometers wide. So the distance from here to here is 3. And he can launch his boat anywhere. Obviously, he's not going to want to launch it backwards here because that's going to, you know, increase your time. What we're trying to do is we're trying to minimize his time, and it tells us how fast he rows and how fast he runs. So if he can either go straight across and then run this here, or he can go somewhere in between and then run the rest, or he can row the entire way, okay? So really his path is from here to here, and then from here to here. But D could slide, D could slide anywhere from here to here. Okay, so if we slide D all the way to there, obviously, you know, that's the most that he would want to go. He wouldn't want to go backwards, or if we slide D to here, then he's rowing the entire way. Did we come up with a piece for this linear part here? 8 minus x, so you should have that part here. And then from here to here, that's a triangle, so 3 squared plus x squared, and then what? Square root it, right? So 9 plus x squared. Everyone okay with that? Okay, and we are trying to, let's see here, as quickly as possible, so we're trying to minimize our time. So we got to find a time equation. Okay, so it tells us how fast he can row. So what is this? Is this a time? What's that called? It's like a velocity or a rate. So what we're going to use is like the distance equals rate times time. So if I want to find time, what would I do with my distance and my rate? Divide by r, right? So you're going to do the distance and you're going to divide it by what their rate is, and that tells you how much time they spent doing that, okay? So this is kind of the key to the problem here. So let's say we're trying to find the time that he was rowing. What is the distance? Look at the picture. What's the distance that he rowed? This part here, isn't it? That's the distance he rowed. Was the square root of 9 square root of 9 plus x squared? Okay, so that's going to go in the distance spot here. Well, that's only if he decides to row the whole way. Okay, but wouldn't this be a true statement even if it was to be? You know, because your x is going to be 8 there, so then it's still going to work. So this will work for any spot, or even if he rows straight across, doesn't this still work? Because if he rows straight across, what's your x? 0, so doesn't that still work with this equation here? Okay, so this equation will work for any spot between C and B. Okay, we just like place it in between so it's easier to, you know, see it there. So our distance that he rows is that, and what's the rate that he's rowing? 6, so 6 goes in the bottom. And then the other part we have to find is the time that he spends running here. So what's the distance that he runs? 8 minus x, and that'll work anywhere in between there. Okay, so we got 8 minus x, and then we're dividing that by the rate, which is 8. And what do I have to do with these 2 times? Add them together, right? Because he rows and then he runs. So I'm going to write this as like 1/6 of 9 plus x squared to the half power to make it easier for the derivative for myself. You guys might be fine without it. This one I'm going to split it into the 2 fractions. So I'm going to say plus 1 minus an 1/8 x. You guys okay with that? You could write it different ways and still get the same derivative. I call that the heart method, splitting that, because you circle this and you circle this, and it looks like a heart. It looks like a heart because you love math, okay? Okay, so now we take the derivative. Well, if you don't love math, math still loves you because you're an AP Calc BC, okay? It at least likes you. Okay, so take the derivative of your t there. Does this look okay to you guys? And then we're going to end up setting it to 0. I'm going to clean it up before I set it to 0. Or I suppose I could clean it up in the same step, but I don't want to confuse anyone. So this would turn into a 6 down here. So really we've got x over 6 square root of 9 plus x squared, or x squared plus 9, either way. And then I'm subtracting an eighth x, or sorry, just an eighth, and I'm setting that to 0, so if I add the eighth over, it would turn into that, right? So I'm going to write here that t prime of x equals 0 when, and this is what I'm doing here. What might be the easiest way to do that? Cross multiply is probably the quickest. You know, it's the same really as doing other things like multiplying by 8 and then multiplying by this stuff, but I'm just going to cross multiply. I think it's easy. So I want to get rid of this square root. How can I go about doing that? Square it all. So before I square it, I'm going to divide by 6, but if you don't, you just have to make sure you square the 6, okay? So I'm going to divide by 6, put it in the denominator here, and then I'm going to square both sides. This could turn into 4/3, couldn't it? So I'd make it a little bit less complex looking, I suppose. So I'm going to square this side, and then I'm also going to square this side, which gets rid of that square root. So this turns into 16/9 x squared. I'm going to subtract this x squared over, and then it equals 9. What's 16/9 minus 1? 7/9. So we've got 7/9 x squared equals 9. What would be your next step there? So multiply by 9/7. So I get x squared is equal to 81/7. And then we should square root it, shouldn't we? So what's the square root of 81? 9. And square root of 7 in the bottom. That was kind of fun. Okay, now what points do I need to, so let's say we put this in as a again. What points do I need to check in my functions? Obviously, I need to check a in there. Or we could check what? Our endpoints, which would be what? So C, my x would be 0, and B, my x would be 8. So 0 and 8 would be the other spots to check. And I've got them on my paper, so I'll give those to you here. So T of A, I've got 1.331. T of 0, I've got 1.5. And T of 8, I've got 1.424. And what are we trying to do? Maximize or minimize this time? We're trying to minimize it, right? So we should be doing this part here. And then answer the question. So where should he land to reach B as soon as possible? So he should land 1.331 kilometers down the river from where he started. Huh? Oh, I just found time. Thank you. He should land whatever this number is, right? What is that? Oh, it's like I've got that on my paper here, 3.402. So he should land 3.402 kilometers down the river. Right? Okay, but this is kind of cool because they did this experiment with dogs. Did I tell you guys this last year? Where, like, this, I mean, it was just like a mathematician guy or whatever, and so I'm sure he just did it with his dog. But he threw a ball, like, into the ocean, and, you know, the dog could either swim to the ball, or the dog could take off running and then cut into the water and swim to the ball. So he threw it not, like, directly out into the ocean, but, like, at, you know, an angle into the ocean. And the dog minimized his time by, like, running to the right spot and, like, swimming. It was cool, you know? It's just like a smart person's, you know, fun time with their dog. Yeah. Huh? The riptide did not get him. Okay, any questions on this one? Okay. There's the rest of your homework. So if you didn't finish the first stuff, finish that up. But then these ones are a little more challenging here. Now, didn't we do 35?
Yeah, we did 35.
Okay, so 35 you can cross off there.
We were going to do 37.
But you guys can, is that the one that I said to skip today?
Yeah.
Or are you just making stuff up? You're just making stuff up. Yeah, do those two.